You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, listeners, and welcome to Common Descent. This is our first episode of the year, 2026. We're looking forward to a whole big year full of paleontology and evolution and Earth history and the stuff we like to talk about. This is episode 234, and this episode's topic is Snails and Slugs.
Yeah, a nice ooey gooey one to begin the year
Starting
with.
off the year, slimy. This will be great. This one, we've gone a long time in this podcast without really devoting attention to gastropods. This is going to be the gastropods episode. We will talk about what makes these animals distinctive, and we'll talk about their evolutionary history and their fossil record. This one was a lot of fun because I did a bunch of research to learn about these animals, and I didn't know a lot of this stuff, so I have a much deeper appreciation for snails and slugs now.
Yeah, they're pretty neat.
This episode has also been a long time coming because it was requested by so many people. As usual, every episode of the podcast is topics requested by our listeners. Gastropods are popular. This topic was requested by Gordon, Devo, John, Aaron, Science Skink, Michael, Lewis, Gemfire, Sophie, August, Big, Charlie, Noah, Dustin, Lou, Brachiophore, Serpentine, IOC Electus, Mads, Dance, Susanna, Rebecca, Maui, Ollie, Toy, Fertifreund. We're about halfway there. Sully, Brett, Soja 17, Sin, Neo, Lewis, Lucas, Jimbo, Jordan, Rebecca, Paleocryptid, Latrodectus, Sam, Stacia, AC, Larissa, Taterboy, Alexander, Daydragon, Lachette, Josiah, Hadley, Jackie, and Paul.
Wow, so many Shelly friends.
So many people wanted us to do this episode. I'm very excited to do it. That's a big list. It's no fungi, but it's a big list.
Fantastic.
Thank you all so much for your input and your suggestions. We greatly appreciate it, and it gives us an excuse to talk about squishy, slimy animals that we might not otherwise have gotten to.
Mm-hmm.
Before we get into the meat of the episode, a few announcements. First and foremost, we are coming into 2026 with all sorts of fun plans for the year, thanks in large part to the support from our patrons. The support on Patreon funds the podcast from top to bottom, from left to right, everything we are able to do, including living, the two of us, having some income from our patrons, paying for hosting the podcast, paying for new equipment, travel, all that stuff is thanks to our supporters on Patreon. We can never express our gratitude enough. In return, we put bonus content up on the Patreon that patrons can access, bonus news, after chat. We do live streams with our patrons. There's merch and stuff. There's all sorts of fun goodies. And at certain levels, when you join the Patreon, you get your name shouted out here on the podcast. We would like to welcome our first new patron announcement of 2026, even though because of the way the recording works, this person signed up last year. But the shout out is coming here in 2026. Welcome to the Radio Chemist.
Welcome, welcome. Thank you so much for supporting us and kicking off 2026.
There are a few exciting things sort of in the works and around this time. First and foremost, this episode comes out the first week of January. If you haven't already, go listen to our end of the year Q&A for 2025. It is, as is tradition, our longest end of the year Q&A yet, coming in just shy of 6 hours long. It was a real question and answering marathon, and then a second editing marathon for Will.
Yes, it was tons of fun, and luckily Q&As are easier to edit than the average recording because there's not a lot of there's not as many repeats and us trying to say things particular ways because we're just answering off the cuff, so it's mostly just getting rid of ums, and so I just got to listen to it, which was delightful. There were so many good questions this year.
Don't let all of Will's work go to waste. Go enjoy and listen to that episode. Looking to the future, at the end of January, we will be celebrating the 9-year anniversary of Common Descent. We'll be celebrating with our traditional annual anniversary live stream. This year, the live stream will take place on Wednesday, January 28th at 7 p.m. U.S. Eastern Time. It will be up on YouTube, public live stream. Anyone is able to join. We will chit chat with our audience. Maybe we'll take some questions if you have them, and we'll make some announcements for what's coming up later in the year.
Yeah, it should be exciting.
And speaking of what's coming up later in the year, this episode will be coming out roughly 1 month before we start releasing our special series for 2026, Poke-E, our first Spook-E spin-off series where we will be speculatively evolving Pokemon.
Yeah, it was a ton of fun.
It was also, I edited that one, a ton of fun to go back and listen to because we had a whole lot of fun conversations. If you're a fan of Spook-E, don't miss it because this is great. And all of these speculatively evolved Pokemon are now honorary members of the Spookyverse. So
Yes.
if you're a completionist, check it out. With the announcements out of the way, let's move on to the news. As usual, we start off every episode by talking about some recent news in the world of paleontology and related sciences. Because of the recording schedule, these are going to be our last news items from the year of 2025.
Yep.
So, Will, they better be good.
I think they are. My first news is about the methods by which it seems ants evolved to make more individuals for cheap.
Oh, the Zerg strategy.
Yes. This is research by Arthur Matt et al. In Science Advances, and the article is a press release from phys.org.
Link in the blog post.
This research is looking at the classic question of quantity versus quality that in nature and in other systems, human society and so forth, that is a constant trade-off that I cannot make as many things at the highest quality as I can if I make it at a lower quality.
Yeah, you want it done well or you want it done a lot.
Exactly. That is not just a symptom of capitalism. That is just physics. I can't put the same amount into numerous things because they're going to take more time to build. And if I'm taking as much time to build a high quality thing many, many times, I won't get as many because, especially if we're talking about animals here, their individuals are going to start dying and your population cannot actually grow the same way. This is a classic conundrum, and figuring out what the pros and cons and what the exact linchpin issues are for how you go from one to the other has not always been looked at, and they were wanting to look at this using ants as the model.
It's a pretty good model.
Exactly. And not only because they are famous for being eusocial and having giant communities and populations, but because they range from million strong nests to individually hunting ants.
Yeah, episode 149, we talked about the diversity of ants.
This brings up a couple of dilemmas on how do you make more individuals cheaper? Because obviously that's what happened with ant evolution is they went from more solitary members to more social species as time went on. But how did they do that? Did they make their workers smaller, or did they make them cheaper to build? Particularly looking at the cuticle, the building material of the ant exoskeleton. And so were they just reducing the amount of ant that they had to develop by making them smaller, or were they making cheaper units, biologically speaking? To investigate this, they looked at the cuticle investment of ants. So cuticle is the outer protective layer of the exoskeleton, but it also forms a lot of structural supports for muscles. So it's one of the key structural elements of the exoskeleton of ants. They looked into this because it is such a critical feature, but it's also nutritionally very expensive. It takes some really particular elements, things like nitrogen and various minerals to build, which are often quite scarce in ecosystems. So, if this was going to be affecting this, it makes sense that this might be one of the selecting factors. Making a thicker cuticle will make you stronger, but it also means you need more resources. So, if you can make a thinner cuticle, you might be able to make more ants for the same amount of resources available to you. They used a large data set of 3D X ray scans that included 880 specimens from 507 species of ant.
Cool.
They measured the cuticle to body volumes. So they were seeing how much cuticle investment was there to body mass. And they found that it ranged quite a bit from 6% to 35% of the ant's total weight. And then they incorporated this data set into evolutionary models of ants to try to see how well does cuticle investment match up with our patterns of ant evolution and social structure. And they found that larger colony sizes do seem to sync up with reduction in cuticle investment rather than miniaturizing workers.
Yeah, they're not smaller, they're just lighter.
Yes, which is why one of the researchers called this the evolution of squishability. That you're making less robust workers, but now you can make more, and that this might lead to some other key colonial behaviors that we associate with social ants. It makes them, less resilient, less protection, which could lead to things like collective foraging, nest defense, and division of labor, because you can't send out a single worker to do the same job that they used to be able to do. You now need to send more or to work together to do these things. And this could also have been an extra layer to the pressures evolving larger colony size. They also found something interesting, which is that reduction in cuticle investment, so same thing, was also associated with diversification rates in ants. So colony size getting bigger makes perfect sense because reducing the cuticle means better use of materials. You can make more ants on the cheap, and that makes sense. Why it is seeming to also lead to an increase in species coming about is not yet fully known. They weren't able to give a full answer as to why this might be. It could be that it might allow ant species to make use of more barren ecosystems of these nutrients. So it might make them more flexible, more versatile in what ecosystems they can adapt to because they are less reliant on these cuticle nutrients, these cuticle ingredients. But this was, it seems, a bit of a surprise variable that popped up, as for some reason it also seems to increase the amount of species that ants were producing.
Yeah, that my first thought was maybe it is just that flexibility. That with a larger colony, you are more adaptable, you're more flexible, you're able to adjust to more different conditions.
Yes. And it could be, I would wonder if the benefits of having a bigger colony and more social species is just that much of a edge, that you are now able to start being that superorganism, which really does just speed things up. They mentioned the fact that the reduction in cuticle leading you to make more individuals, and more individuals allowing you to work together better, which leads to less need of strong armor, could end up with feedback loops that could really start to speed up this process.
Yeah.
And it could just be that was evolutionarily successful in and of itself and spawned the addition of new species. They compared it as a similar, that you could see it as a kind of similar pattern to multicellularity, that individual bacteria are tougher than any one of our cells and more complex in many ways in what they can do, but our cells working together can do more than a bacteria can do.
Yeah. Fascinating. That's really the question of this quality quantity shift is really interesting because, for another really great example of that, listeners, go check out episode 88, where we talked about teeth.
Mm-hmm.
And how one of the things that distinguishes mammals is the opposite situation,
Yes.
where reptiles and fish and a lot of other vertebrates have relatively simple teeth that they can grow and replace indefinitely. But one of the hallmarks of mammal evolution is much more specialized, complex, specific teeth that we only get 2 sets of.
Mm-hmm.
Which also is associated with diversification and success in the mammal lineage. So it is fascinating to think about when and where quantity and quality are each respectively useful.
Yeah.
And each more prone to lead to success in that group.
Absolutely. And this kind of, approach and looking at these kinds of features could also be applied to other systems, human systems and other groups. They mentioned that termites are another group of interest. They have not, looked into them yet, but that they hopefully will be able to test if termites took a similar route to eusociality and bigger colony sizes, or if they did something different.
Interesting. This also makes me think of cars.
Yes.
That was my first thought when talking about reducing the cuticle and the weight of each individual. And it does make me think of like the big Cadillacs from some decades ago, which were reduced to modern day, more lightweight, thinner outer shell cars for a number of reasons, but one of which is they're cheaper to make that way.
Yes, absolutely. It always makes me think of Back to the Future when they're trying to race and wrestle with things with Biff, and he's like, ram him, and he's like, are you kidding? That thing is solid steel. It will tear through us.
My brother and I used to play Rush 2 Extreme Racing USA, and when I wanted to be mean to the other cars, I would drive the Cadillac.
Yep.
Which could just mow other cars off the road. Well, my first bit of news is not at all related to that. It's about cats. Actually, it's not about cats. It's about false cats. These are fake cats.
Oh.
This is research describing a new species of false saber-toothed cat exhibiting an anatomy and lifestyle we haven't seen before from this group of animals. This is research by Qigao Jiangzhua et al. In Proceedings of the Royal Society B, and in the blog post we'll link to a press release on Sci News by Enrico de Lazaro. Nimravidae is a family of carnivorous mammals known as the false saber-toothed cats. We talked about these a bit in episode 214 because they are one of the earliest groups of true mammals to develop saber teeth. Those long blade-like canines that stick down out of the top jaw. They're known from the Eocene to the Miocene epoch, so largely in the first half to the middle of the Age of Mammals. Mostly they're known from North America, but there are examples in Eurasia and Africa. They are also famous, like a lot of other groups, for being extremely cat-like. Their bodies are very much like true cats. Their teeth and heads are very much like true cats. So while true saber-toothed cats are cats, they are felids, nimravids are shockingly convergent to true saber-toothed cats. Nimravids, however, are much older than true saber-toothed cats. In fact, they are not only one of the earliest branches of carnivora, the mammal group that includes dogs and cats and bears and stuff. But nimravids were also the first group of carnivorous mammals to get big, to develop into large, specialized carnivores.
Yeah.
And therefore, they're interesting in studies of mammal evolution because they represent the niches and lifestyles that were explored by the earliest large mammal carnivores. This paper describes new fossil remains that were found at the Qingxueying Formation in northern China. These date to the middle part of the Oligocene, so just under 30 million years old. This is a new genus and species, Tautenimravis songi. It is relatively large, and its jaws and teeth are unusual, compared to other nimravids, and indeed compared to other cats, including saber-toothed cats. Typically, like I mentioned, nimravid jaws look like a saber-toothed cat's jaws. And a saber-toothed cat's jaws look a lot like a lion or tiger's jaws. They have a very similar setup. This new genus of false saber-toothed cat does not have saber teeth.
Huh.
Its canines are short and heavily built. The mouth, of like the roof of the mouth and the snout overall, are unusually wide in their shape. And whereas in many cats, the premolars just behind the canines are smaller than in a lot of other animals, these have enlarged premolars, so much so that there is no gap between the canines and the cheek teeth, which is a very common feature in a lot of carnivorous mammals. All of these features lead the authors to suspect that this was a nimravid that was probably specialized in delivering a very powerful bite. Not powerful bite like a tiger, but powerful bite like a hyena.
Yep.
That this was very possibly a bone-cracking nimravid.
Excellent.
This is interesting because not only is that a habit that has never been observed in nimravids before, there aren't any cats that do that.
Yeah.
We don't have like specialized bone-cracking modern felids. There aren't saber-toothed cats that were specialized to this extent. This is something in this group that is so cat-like. This is something they did that hasn't been done by cats. And the authors talk about that this fills in an important part of nimravid evolution. Not only is this an Asian species, which we don't have as many of with nimravids, not only is it large, which supports the understanding of when nimravids developed their large size, but it adds to previous research that shows that nimravids were doing things that true cats didn't do, and probably they were able to do that because they were the only major group of carnivorans around in the early part of the Cenozoic. Right. By the time true felids showed up, there were also dogs and bears and hyenas.
Yep.
Things that were already doing those jobs.
Yes, exactly. That you're not going to want to compete with.
Yeah, and that you're probably not even going to be able to. Like, if you want to crack bones, you have to go find a place that doesn't already have a dog or a hyena or a bear that's doing it. And once you get past a certain part of the Cenozoic era, you're not going to find a place that doesn't already have a dog or a hyena or a bear that's doing it.
Yeah, that isn't also like lacking all trees because it's Arctic.
Yes, exactly. You're in the middle of the desert.
Cool. That's fascinating. And that point that they might have had the opportunity because of when they were the dominant predators is very interesting. I hadn't thought of that until you said it. And that's a really cool concept. It does make you wonder of like how weird would cats get if they weren't competing with others. And because I hadn't even thought of the fact that there really haven't been bone crushing cats.
Same. Yeah, I hadn't really considered that.
So this is one of those cool things of it gives more appreciation to nimravids that these were not just false cats. They were their own group doing some cool things that cats didn't do, but also how important it is to consider who a group is evolving with in that. It's like, well, why didn't cats do this? It's probably not that cats couldn't, we absolutely could expect if there was a mass extinction and cats made it through, all the house cats made it through, but many other mammal predators didn't, that we would see hyena-like cats in a handful of million years, but they just haven't had the chance to do that. And that's really awesome. Well, my next bit of news doesn't, well, it kind of has. There's a little bit of overlap because it deals with some mammal bones, but it has more to do with my first news because this one's about bees.
We're still in Hymenoptera.
Yes. This is some interesting trace fossils of bee burrows found in places both location wise and what the burrow is in that we've never seen before, because these are bones found in a cave.
Ooh.
These are awesome. This is research by Lazaro Vignola Lopez et al. In the Royal Society Open Publishing. And the article is by Taylor Niccioli in CNN News. So bees, very famously, we think of them as eusocial insects like ants.
Episode 111.
But the truth is, many, many bees, the vast majority actually, are solitary.
Yes. Not hive forming the same way.
They may live in groups, but they aren't working together to raise young. Each female bee makes their own nest, their own burrow, or whatever it is, lays their own eggs, feeds their own young. There is not communal help, even if they are grouping together. And when we say the majority, like 90% of bee species are living this way. Think of your carpenter bees that burrow into the sides of your houses, and many of them dig tunnels down into the earth. There is fossil evidence of bee nesting and these kind of burrowing bees going back quite a ways. We have trace fossils of burrowing bees from the Cretaceous to very recent. This research is reporting a new kind of bee trace fossil from the late Quaternary, so about 20,000 years ago. It was found in a cave deposit on the Caribbean island of Hispaniola and has been given a new name because we've never seen anything like this in fossil traces or modern bees.
Ooh.
This is Osidum almontii, and these traces, these bee burrows, have been found in the cavities of mammal bones.
Cool.
It's very cool. They have found them in various bones. They found them in tooth sockets. So in the mandibles where teeth used to be, those they found burrows in there, pulp chambers, and vertebra backbone canals.
Cool. So they didn't burrow into the bone.
No.
The bees weren't excavating holes in the bone. They were burrowing in holes that already existed there.
Yes, they were finding
Somehow,
pockets.
I don't know if that's better or worse, but it is different.
Yep. A
bee burrowing into a tooth, building a little nest in a tooth socket.
Yes,
is adorable and gross.
Yep. Yep. It is very, very interesting. This is the first time bees have ever been recorded using bones as nests for their eggs, modern or extinct, which makes this a very unique and interesting record. It's also very surprising because we also don't see bees nesting in caves very often.
Yeah, that is interesting.
That is not a usual place. There are some that nest in shaded areas, and there are nocturnal bees. So dark areas aren't completely out of the question, but thus far, and at least as far as the reports are aware of, there's only ever been one recorded instance of bees nesting in a cave for modern bee species that we know of.
Interesting.
So
these were bony cave bees.
These were bony cave bees. There could be multiple reasons why they were nesting in a cave. Consistent ecosystem, temperatures and moisture could be a big reason. It could, be protecting them from harsh weathers, rains and flooding and things like that. It is notable that they did not nest in the soil of the cave, but in bones in the cave. So it is likely that it's not that the cave soil was ideal and that it may have been not ideal. So maybe it was just something about being in a cave that was helpful, and less so the actual makeup of the cave. It's also a surprising find because this fossil site, which is known for many other fossils and many bony remains, insects are not known typically. They find very few invertebrates in general. They find snail shells, but not insects typically. So this is also an exciting find for this deposit. The very muggy and muddy substrate of the cave preserves bony animal remains quite well, but not insect remains. So this is one of the first, and few evidences of insect life and residents of the cave that has been found for this fossil site as well. They don't know what kind of bees made these burrows. We don't have any of the remains, so we don't know whether it's a extinct species, new species, or modern species.
Sure.
Any of
And like you
those.
said, 90% of bees are doing stuff like this.
Yes,
So it's hard to narrow down.
exactly. They were able to say it's similar to certain groups of the family Halictidae has similar medium-sized burrowing bees that would make similar traces to the burrows that they see, because they do have scrape marks and traces on the burrows. So probably a bee similar to some that we know, but just not one that we can confirm what kind it was. This is also exciting because it fills a bee fossil record gap for the area. Most bees are not well known. All other bees known from the Caribbean are known from amber and are typically much older, dating around to 20 million years ago. So having a much younger trace fossil of bees in the area gives us a bit of info that we were lacking. And they were able to get some info on the behavior and practices of these bees. Features of the burrows. They did scans of them and were able to see smooth inner walls. This is what led them to associating it with that family of bees that has similar proclivities and sizes. Micro CT scanning of the bones also shows evidence of multi-generational use of the same cavity. So
Cool.
bees coming back through multiple nesting seasons, up to 6 generations of bees coming back to the same single hole. And the high abundance of nests found throughout the deposit indicate that the cave was likely used over long periods and probably by many, many individuals as a congregation, an aggregation of solitary bees. So not eusocial, but a communal nesting site for individual females nesting.
And now this does actually bring up one of the benefits of nesting in a cave.
Yeah.
Is that a cave is going to be one of the few places where bones are going to survive like that.
Yep.
Like if you want to nest in a bone in a rainforest, you're maybe going to get one nest out of that.
Yes.
Before it gets eaten or decomposed. But in a cave, it's a nice stable environment and bones can last in a pristine condition for a long time.
And speaking of what this might tell us about their overall ecosystem, they noted that this also might indicate particularly poor nesting conditions outside the cave.
Oh,
that
sure.
This might give us some insights into what the overall area was like, and that this might have been one of the few areas that was ideal for these bees, since it seems they were concentrating here so frequently. So this has just led to a whole bunch of really interesting insights, some new insight, new views on what bee behavior can entail. And they pointed out that it means we need to keep an eye on the bony remains we find, because they might be hiding trace fossils of a behavior we didn't know existed until this study.
Yeah, that's so cool. It is very common that we find animals in the fossil record that are, have a different anatomy and are maybe, eating something different, like that nimravid that I just talked about.
Mm-hmm.
But to find fossil evidence of a population of very familiar animals from very geologically recently, only 20,000 years ago, doing a thing that none of their living members is known to do is really interesting. That finding bees doing something weird 20,000 years ago makes me wonder if either bees are doing this today and we've just never noticed it, or this disappeared for some reason.
Yeah.
What changed? Or was it that this was a thing that existed for a blip in time?
Yeah.
This was one strange group of bees.
Exactly. That for some reason, living on this island in the Caribbean, this is how they survived in this very unusual way. It's so cool.
Fascinating. Well, I have to admit that your two newses are both better segues into the main topic of discussion for this episode. But for my last news, I have a thing about dinosaurs.
Woo!
Specifically, new insights into tiny armored dinosaurs.
Oh.
This is research by Wenjie Zheng et al. In the Journal of Vertebrate Paleontology, and we will link to an article on the Natural History Museum website, the Natural History Museum, where at least one of the authors of this paper is from, written by Emma Catton. The tiny dinosaurs in question belong to the species Liaoningosaurus paradoxus. These are a pretty, I don't know if they're famous, they're a little bit infamous, ankylosaurs. So ankylosaurs are the armored dinosaurs. We talked about them in episode 69. Liaoningosaurus is known from the early Cretaceous of Liaoning in China. Several specimens are known, and one of the things that is unusual about them is that they are all very small.
Mm-hmm.
The article on the museum website said that all of the specimens are under 40 centimeters,
Oof.
which is extremely small.
That's so tiny.
This has led to, this and other things have led to some confusion about what exactly was going on with these tiny ankylosaurs. Some researchers have proposed that they might be juveniles, right? They might be babies, that they could also just be miniature ankylosaurs, a species that was very small for some reason. There's even been suggestions that they had an unusual lifestyle. Liaoningosaurus is the species of ankylosaur where one specimen was found associated with fish remains.
Right.
That led to the suggestion that they might have been swimming or possibly even eating fish. There's a lot of confusion around this particular species of dinosaur. But one thing that has not been done with Liaoningosaurus before is bone histology. Right, examining the internal tissue structure of the bone to learn about the dinosaur's life history. Here, the researchers performed bone histology. They took samples from 2 different specimens, one of which is one of the smallest known specimens, and the other one is the largest specimen. The largest specimen has they compared their femur length, and the largest specimen has a femur that is twice as long as some of the smallest specimens. So they're all small, but there's some significant variation in their smallness. The researchers took bone samples from ribs, arm and leg bones, and osteoderms, the bony armor on the body, all to examine, do we see, what can we tell about the development of these animals? Now, as we have discussed before, dinosaurs grow their bone. This is also true of reptiles like crocodilians. They have kind of like tree rings in the bone, and the development pattern of bone tissue can tell you about their growth patterns. The researchers found in both of these specimens no growth lines.
Okay.
And evidence of very rapid growth, which suggests the lack of an annual growth line suggests that both of these specimens had not made it to a year.
Exactly, yeah.
That these were not just juveniles, babies.
Itty bitty babies.
And in fact, the smaller specimen in the bones even had a line in the bone tissue that is known as a hatching line. That is the line of tissue laid down at the time of hatching from an egg.
Huh.
Which means that this smaller specimen was a hatchling. This thing had just come out of an egg.
Aww.
Not only is that extremely cute, we don't have any ankylosaur hatchlings in the fossil record. This is the first one. There's very little information about ankylosaur growth and development. So this is an unprecedented look at the earliest life of armored dinosaurs.
That's so amazing. Like, I expected that the answer was probably going to be they were younger, but that is so young.
Yeah, that was... Now, they didn't... As far as I could tell, they didn't have, like, this many days old. But
yeah.
The impression I get is that if you still have your hatchling line, you're, like, maybe weeks, maybe months old, but pretty fresh.
Yes, well under a year.
Yes, exactly. Now, interestingly enough, what this doesn't give us is very much information about this species, because it means that we don't have any adults. So this wasn't a tiny species of ankylosaurs. These were babies of some adults that remain undiscovered. Not the first time that's happened with dinosaurs. I believe Musaurus was one of those, which is early Jurassic, I think. Musaurus, maybe Triassic, which was named Musaurus is mouse reptile. And it was named that because it was tiny. And then later we found adults. But these do give us insights into the early development of ankylosaurs as a group. The authors, at least in the bits that I read, don't go into a ton of detail in that as of yet, although they do point out that this hatchling ankylosaur has osteoderms, has bony armor, which is something that has been questioned in the past, right? When did that armor develop during the life of the animal? This shows that at least some of that armor was in place at hatching.
Mm-hmm.
And these little tiny dinosaurs will give us lots of examples to look at for understanding the details of early ankylosaur development.
That's so cool. We've mentioned it many times on the podcast that though baby dinosaurs are by no means a near impossibility or anything, like we find baby dinosaurs, but they are quite rare. And not only is it that small animals tend to be much more fragile and it's much easier for them to be destroyed or eaten, like swallowed whole and not left any remains, but you're also only a baby for a short while. So it's a very narrow range of their lifespan that we can get a look at what they were like in the early years. So the fact that we found a handful, of specimens that seem to be less than year and almost brand new born is so exciting. And yeah, ankylosaurs, which I forget that we don't know much about them as babies, and that's awesome. Just little baby armored ankylosaurs.
It really is. It's the excitement of finding a new type of fossil, similar to what you were with the bees, where most of the relatively recent bee fossil record is amber. So finding a different type of remain for this group of animals, regardless of what it is going to be informative in new ways. Finding a baby dinosaur is informative in ways that an adult can't be, which is really exciting.
Well, like you mentioned with the armor, like this doesn't mean all ankylosaurs were born with armor. You might have had armorless and baby ankylosaurs. This might have meant that they were having to deal with predation earlier than some others or something like that. But we now know it's possible for them to have hatched with armor. And if it's possible for this species, it's possible for other species. So it's something that we should expect if we find babies in the future of other species. They might have been armored from day one.
Yeah, it does make me wonder when tail clubs developed.
Yes, exactly.
I don't know if Liaoningosaurus was a species with a tail club, but I do want like Ankylosaurus. Did you come out of the egg with like a tiny little tail club? Did you already have a little club?
Were your tailbones fused into that rod the way adults are, or did you have a flexi tail to fit inside the egg?
Yeah, or was that a maturity thing? You developed that when you became an adult so that you could fight other ankylosaurs with it.
Exactly. Oh, so cool.
So many questions. Well, hey, speaking of tiny, cute things covered in armor.
Excellent.
So I did it. I found it. I found the connection. That's the news. And therefore, we will take a short musical break and then get into the main topic of the episode, gastropods, better known as snails and slugs, and frankly, better known as snails. We'll get into why that is. After the episode, we'll jump into who these animals are, and we'll start talking about their utterly fascinating anatomy.
They're so cool.
Snails and slugs comprise a group of animals that are called gastropods. Gastropod, a word that means stomach, foot, because that is most of what a gastropod is.
Yep.
Gastropods, the group Gastropoda, are in the larger group called mollusks. Mollusks includes three sort of big deal, famous, very diverse and speciose groups: cephalopods, which are octopus, squid, etc., which we did an episode about like 9 years ago in episode 16,
Yeah.
and bivalves, which are clams and oysters and your various hinged shelled things. And then gastropods, which makes gastropods arguably the second most charismatic mollusks.
Yeah, no, absolutely. No offense, bivalves, but snails got you beat in that category.
They sure do. This is a trio of lineages that I, for a long time, would look at and think, that's weird that those three are related. That's weird that that's a family.
Mhm.
But as we get into the anatomy of these groups, we will see that it is not so strange after all.
Yep, I remember watching a video on the evolution of cephalopods, and as they went through, I went, "Oh, I get it. I get it now."
Yep. So we will see. Now, for me, when I think of a mollusk, the default image that comes to mind is a clam. That's
Yep.
like the classic picture of a mollusk, which is incorrect. There are in the modern world somewhere in the vicinity of 80 to 90,000 known living species of mollusks, clams, octopuses, etc., etc. Almost all of that, something like 60 to 70,000 of those species, are gastropods.
Yeah.
The default mollusk is a snail. That's
Yep.
what a mollusk is.
Well, and like as we will get into, of those three groups, only one of them has invaded the land, and that makes a big difference.
It sure does. And in fact, most living gastropods are marine. More than
Yes.
half are ocean dwellers. Most of the rest are terrestrial.
Mhm.
There are plenty of freshwater species, but by number, it's you either live in the ocean or you live on land. And then freshwater is the third least common option, which is very interesting.
Yeah, it's interesting how often that happens with stuff where that freshwater seems like it should be the easiest because we think of the ocean as a hard place to live because we are bad at salt.
Mm-hmm.
But actually, the freshwater is lacking a lot of things that groups like this need.
Yes, and it's also full of other things.
It really is.
Freshwater is really packed. Living gastropods are found. Not only are they found in oceans and on land, they live in almost every habitat on the planet. They are found in rivers and lakes. They're found on coastlines, in reefs, in deep sea trenches. They are found in near polar environments. There are snails that live in deserts. And as I saw it pointed out in multiple references that I read, they are commonly found in backyards.
Yep.
They are, in fact, I believe gastropods as a class, I think it's a class in Linnaean taxonomy, are the second most diverse class of living animals, second only to insects.
Yep.
And they're about as widespread as insects, and insects don't live in the ocean.
Yeah.
They are truly magnificently successful and widespread animals, despite being basically a little pile of snot.
Yeah, like they get treated often as like very uninteresting animals, but they are really good at being a snail or slug.
Yeah. So whereas insects and arthropods have a hard exoskeleton, right? They've got jointed legs, they've got an exoskeleton. Worms are many different groups of just sort of tubular, long-bodied animals. Obviously, vertebrates have interior skeletons. Mollusks are distinct for having at its core, a fairly simple body plan.
Mhm.
All mollusk bodies generally consist of 4 parts. The head, the foot, which is not a foot like our foot, but it's their muscular moving or gripping organ. What is called the visceral mass, which is basically the rest of it. It's the body. It's where all the organs and stuff are.
The guts.
It's where all the good stuff is. And a shell.
Mm-hmm.
You may recall from our cephalopods episode, cephalopods ancestrally are shelled. Some of them today are still shelled. Bivalves obviously are. I don't know if there are any shell-less bivalves. I wouldn't be surprised if there are.
Like you get some where like the shipworms that came
Oh
up in our piranha
yeah.
plants, those are bivalves that have made their shell into a little Pac-Man mouth to bore through
Yes.
wood. So they are less shelled, but they are still very reliant on that shell.
Yes. And then of course, snails. It is the famous thing about snails is that
Mhm.
they have shells. So let's get into some more detail about gastropod anatomy, specifically what it is that makes up the pieces of a gastropod. On the front of a gastropod is the head. Like a lot of animals that have heads, this has eyes and sensory organs. Snails typically have tentacles that
Mhm.
stick
Mhm.
off of the face. In some species, I think this is mostly a land snail thing, the eyes are at the tip of the tentacles.
Yes.
So they have stalked eyes that can move around. In a lot of other species, the eyes are down at the base of the tentacles, and the tentacles are used for different sensations. They have a mouth, which in some species it forms a long tube, like a
Mhm.
proboscis that comes out. In others, it's just a mouth flat against the face. And inside the mouth is a radula.
Yeah.
The radula, this is another mollusk feature. It is a tongue, kind of. It's not an actual tongue, episode 192, but it is tongue like and covered in these chitinous bristles. So it's kind of like a little sandpaper, kind of like a cat almost. It's
Yeah.
got that sort of like
It,
scratchy.
it's and when you look at it under a microscope, it looks like a chainsaw tongue.
Yes.
Like a tongue made out of the chain of a chainsaw. It's probably one of my favorite pieces of animal anatomy. Radulas are way up on my list of just cool body parts.
They are very cool. Classically, what snails are using this for is for scraping up algae,
Mhm.
right? They're scraping algae or bacteria up off of rocks or whatever. But there's a whole bunch of different diets that snails and slugs can have. Many of them are herbivorous. They're eating either algae or plants. There are some that will eat land plants.
As all gardeners know.
As all gardeners know, they'll eat fruits, they'll eat leaves. There are some that eat wood. There are also a bunch of snails that are known to eat fungi. So they're pretty, and I believe that there are lots of species, particularly here on land, that are kind of generalist,
Yeah.
that will go after a variety of foods. And very famously, there are some snails that are carnivores. We'll talk a bit about those as we go throughout the episode. Also, this is a thing I didn't know. Maybe you knew this. Some species of snails have a crop in the body where they
Oh.
collect sand grains to grind up their food, like birds and crocs do.
Oh,
How about that?
that's awesome, man. They're just such little like they're just teeny tiny herbivores, like in so many ways.
Yeah.
Like obviously that's what they are. They're eating plants, but they have features of bigger herbivores
Yeah.
and stuff,
They're
and that's
just
cool.
little goo crocs.
Get better and better.
Then, of course, the visceral mass, the body, the whole body. Snails have basically all of the same basic organs that we expect from other animals. They've got a heart, they've got stomach, intestines, kidneys, liver. They've got all the sort of stuff that you need to be an animal. And then a foot. The foot of snails and slugs is basically just the whole bottom of the body. It runs along the bottom of the body. It moves using a combination of muscles and hydrostatic pressure. In land snails, this is often just, it lays on the ground and pushes them along. In lots of marine species, the foot has like wings on it and it expands in these different shapes and helps them to swim. There are a lot of swimming species of gastropods. Then there is a very special structure called the mantle, which will sound familiar again if you're familiar with cephalopod anatomy. In snails, the mantle is sort of like I think it is named for looking like a cloak. It is a cloak that surrounds the body, the visceral mass. It surrounds the body and does a few things. One, it protects the body, right? It's like an outer layer of skin, in quotes. In Snails and Slugs, there is a fold in the mantle that forms the mantle cavity, which is a very important hole in the body that contains things like the gills, the butt. A lot of exchanging of things with the outside world happens within the mantle cavity. The mantle also is responsible for secreting the shell. This is also true in cephalopods, it's also true in bivalves. In a snail, the mantle is the layer that lays in between the body and the shell around it.
Yeah, it's kind of like how your fingernails grow from your cuticle. That is
Yeah.
the part that produces the nail. It's that structure for the shell.
Yes, the mantle is its job, right? Part of the job of a snail's body is collecting minerals from the environment, usually calcium carbonate, and then using that, secreting that in layers to deposit a shell. Again, same way that cephalopods do it, same way that bivalves do it. And now we're going to spend a whole bunch of time talking about the shell because the shell is such an iconic and important and interesting aspect of snail anatomy.
Yeah.
A snail shell, this feels like another one of those situations where I feel pretty confident that I don't have to explain what a snail shell looks like. That like you've seen a snail, you know what a snail looks like. The snail shell surrounds the body. And in many species, the whole body can actually retract into the shell, typically the last cavity of the shell. Generally speaking, gastropod shells don't have different chambers the same way that we think of like a nautilus shell, but there is like that last curve of the spiral is where the visceral mass sits inside, and they can pull the head and the foot inside the shell to protect themselves.
Yeah, I think that's something people might not always realize is that the guts and everything are up in the shell at all times.
Yes, like a
And
turtle.
like a turtle. The foot and head that you see outside is just the foot and head. All the guts, all the organs, all of that visceral mass is inside the shell at all times. If you were to open the shell of a snail, even when they aren't retracted, you would see a whole bunch of snail left in there, which is the visceral mass.
If you've ever eaten snail, like eaten escargot, a surprising amount of snail comes out.
Yeah.
Because it isn't just the head and the foot; it's the whole body is coming out.
Because I think a lot of people, it's easy to get the image because it's how cartoons show it, that the shell is sitting on top of the snail, but in fact, only a small portion of the snail is outside, and that's the thing we think of as the animal.
Yes. It is looking at that sort of detailed anatomy, you can really see the family resemblance between snails and clams.
Yep.
Like a clam, really the only major difference is that a snail has a head sticking out.
Yes.
Other than that, it's the body's in a shell. You have a foot that you use to move around or grab onto the floor. Snails just also have a head.
Yes.
Now, one of the big differences between snails and bivalves, as the name implies, have two shells. That a clam is two parts of a shell that have a hinge. Snails, generally speaking, have a single shell. It is one shell, the body goes in and it comes out. They are, in fact, the gastropods, an older name for this class of animals was univalves.
Oh.
They are single-valved shelled animals.
They only appear to virgins, and they, like...
Now, many species of snails have an operculum, which is a hardened little structure that basically acts like a trapdoor. When they pull themselves in, they pull this operculum barrier up against the aperture, the opening of the shell, so that they close themselves in like a little box turtle. A snail's shell is not like a hermit crab, which goes out and finds a shell. A snail's shell is part of its body its whole life. In fact, the shell begins forming in the embryo and then continues forming during the larval stage. Snails, like a lot of invertebrates, start out as larvae and then turn into adults. And in fact, the larval shell, which is called the protoconch, I believe, is sometimes visible on like the tip of a snail shell. Like you can look at the adult snail shell, and then at the end there's like a little special patch that is its larval shell that is still hanging on.
which is like so feels like a D&D or Lord of the Rings thing of deep inside this creature is its first shell, like the
Yes.
beginnings.
The shell it grew in the womb. The shell that its mother gave it.
Yeah, it's like if we still had our baby teeth on the tip of our adult teeth.
Yes.
Cool.
Snail shells grow continuously throughout the life. They don't grow quite like tree rings. This is something that comes up a lot, especially in paleontology, when we're studying like corals or clams. Some animals build their shell or skeleton annually. And so you get these nice annual layers that you can then calculate how old it was. Snails don't necessarily grow like that. And in some species, they actually will remodel the shell. So the shell actually does change shape over the course of the life of the animal, and it's reabsorbing and changing the shape. But there are some studies that have found that as the shell grows, in the ones that aren't remodeling it, you can test isotopes throughout the growing history of the shell, and oxygen isotopes will tell you the temperature that it was when the shell grew. So by looking at the isotopes, you can get yearly growth, which is pretty cool. So it's still in there.
Yeah. Also, such a cool concept that some snails can reshape their shell because
Yeah, so interior redesigning.
yeah, because I was always under the impression that like yeah, they just grow from the edge and you're stuck with whatever was grown when you were
Like
younger.
a nautilus.
Exactly. Here you can actually do some reshaping, which makes it very versatile.
Yes. The one example that was mentioned, and where whatever reference it was that I read that was cone snails. Cone snails remodel the shape of the shell, apparently.
They would. They're sneaky.
They're gonna come up again. The shape of snail shells is remarkably variable. There are so many different ways that they can form. Broadly speaking, there are three categories. The classic image of a snail, if you're picturing a snail shell in your head right now, it is almost certainly a conspiral shell. The shell is a hollow tube that coils around an axis, creating this sort of helical shape, like an ice cream cone coming out of the soft serve.
Yeah.
Some of these spirals are relatively loose. Some of them are really tight, rapidly turning spirals. Some of them are relatively flat. It spirals outward, but just a little bit. It's mostly a flat shell. Others are long and pointy. They're called high spired. The spire is that long, pointy part of the shell.
Cool.
The shape of these spirals, right, whether the spiral is flat or wide or whatever, is not reliably linked to the relatedness between snails. The shapes have evolved over and over and over again. They just are constantly throughout evolutionary history experimenting with shell shape.
Yeah, very, very flexible feature.
Far more rare among living species are planispiral shells, which are coiled in a single plane.
Right.
So, like an ammonite, like a nautilus, or if you ask a kid to draw a picture of a snail,
yes,
there's a good chance they're going to draw it as just a flat spiral. That is a planispiral shell. There are snails today that have shells like that, but they're much rarer than the cone-shaped shells. And then there are the non-coiling shells. Shells that just kind of look like a clamshell.
Yeah.
Right? There's no coil to it. It's just sort of like a clamshell. Snails with this shape are generally called limpets.
Mm-hmm, mm-hmm.
If you have heard of limpets, that's what these are. This is also not a single group of snails. The limpet shape has evolved over and over again. And apparently, at least in some of them, the larvae have a coiled shell.
Oh.
And then as adults, they lose the coil and they have just the clam-like shell.
Huh. That's interesting.
Yeah. Speaking of interesting, unusual things, one more brief note about the diversity of shell types. I would like to introduce you to a family of snails called Juliidae, which are commonly called the bivalved snails. These are snails that have a two-part hinged shell like a clam.
What?
They look like a clam. They even have a structure called a tether, which attaches them to a substrate. It is a snail doing its absolute best impression of a clam.
That's crazy.
They can also retract fully inside and close their shell around them. It's just a clam.
That it looks like something someone made up. Of someone
Yeah.
went, oh, clams and snails are related. That, you know what would make a great character is a clam snail, and just that you just drew them together. And if I had seen this character show up in something, I'd be like, oh, that was a very clever artist. Good job. No, that's just a real thing.
One of the giveaways that they are not clams is that their larvae have a single shell that is coiled
Huh.
and are swimmers.
Like that.
So they just they are a snail that turns into a clam.
Yes, and like convergently, it's not that they kept the bivalve shell or something like that. They came up with this on their own.
Yep.
Which must have been really awkward when they went to show it off. And I just came up with a new invention.
I came up with this great idea.
Ridiculous. I love them.
In addition to varying in the shape of the shell, there's also a lot of variation in size. The smallest living snails have shells that are, half a millimeter long. They can be very, very, very tiny, and they can get shockingly large. The largest land snails are giant African land snails, which I believe have been introduced and are invasive in a whole lot of places.
Yeah, I think they're in Florida.
Their bodies can grow up to 40 centimeters long, so a little bit over a foot, and they can weigh a kilogram. That's 2 pounds of snail. And in the ocean, there are Australian trumpets, a type of shelled snail from down in Australia, whose shell can be almost a meter long. I think they grow to like 90 centimeters long. There's a 3-foot long snail shell, and the whole animal, shell and all, can weigh up to 18 kilograms, which is 40 pounds. So, like, this is a snail the size of a toddler.
Yeah, if these snails Voltroned, they would be as much as me.
Yeah.
That's so big. I knew they got, because like conches get huge and whatnot. I did not actually realize they got that big.
The shell serves a whole bunch of different functions, like the shells of most animals. The most obvious one, of course, being defensive.
Mm-hmm.
The shells often have thick shell walls. The surface of the shell in some species is very smooth, which makes it hard to grab a hold of. And in others, have lots of knobs and spines.
Yeah.
There are some really cool looking snail shells that are just covered in these protuberances that also are helpful for defense. In fact, researchers have found that in habitats with lots of predators, it's more common for snails to have thicker shells and larger spines.
Yeah.
And in fact, there was one experiment, I think this was from the 90s, where they placed snails in water where crabs had previously occupied and eaten snails. And the snails placed in there grew thicker shells. So the shell is very much a defensive structure.
That's awesome.
Now, freshwater and land snails tend to have smoother, thinner shells.
Mm-hmm.
And part of that might be that there's there's no crabs around, or at least not as much, but also possibly because calcium carbonate is not nearly as abundant outside of the ocean. That there's just less resources available to build a nice, thick, beefy shell. Also on land, another really useful aspect of the shell is that it helps preserve moisture. Mm-hmm. Snails are slimy and gooey. They need to prevent themselves from drying out. This is why salt is bad for snails.
Yes.
To help not desiccate, the shell is a little trap for wetness.
It's a little land scuba suit.
There are also snail shells that are camouflaged, that have different colors on them. There are carrier shells, which are types of snails that cement other shells onto their shell. and build a little like shell made of stuff.
It's so messy looking, and it's very cool.
And then there are a lot of snails that are burrowers, especially burrowing into the seafloor. They often have a more streamlined shape to their shell. There's even, I was reading some bit of research that was talking about the angle of a snail shell off of its body often relates to how it moves.
Yeah.
That, like, if the shell is sticking straight up, it's more balanced and stabilized up there. Sometimes it's angled in the direction that they're moving. So the different shapes and proportions of the shell can vary quite a bit by lifestyle.
That made me think of a video that I saw of a snail bridging a gap, crawling across a gap.
Yes, I know what video you're talking about.
And it stretches its face across, and like the head just keeps stretching because they're elastic creatures. They're so stretchy.
Right.
And once it gets its head across the gap, and the shell has remained stationary this whole time, it puts its face down on the other side, and then the shell goes whoop,
Yep.
and gondolas across.
And then it pulls the foot over. Yeah.
That's not fair. You don't get to move yourself like that.
One other fascinating aspect of the shell that comes up a lot when you look at, classifications of different species, but also their ecology, is the chirality of the shell, which is the direction of the coil.
Yeah.
Most species exhibit dextral chirality, so right-handed, which means if you hold the shell with the tip, right, the pointy part, facing upward, the aperture, the opening where the head and foot would come out, opens to the right. It is right-handed coiled. But some snails are sinistral, left coiling. This, in some groups, this is different. So like these species are more likely to be coiled this way. It can also happen generationally. Like parent snails can give birth to a baby snail whose shell coils in the other direction.
Oh.
There are even some cases where the coil direction changes during metamorphosis.
What?
The larva coiled one way and then the adult coils the other way. And when you have that little protoconch on the tip of the shell, you can see that the coil changed.
What?
Yeah. There was a famous story recently of a snail, I think named Jeremy, who was a left coiling snail that had a long story about not being able to find a mate because the coiling of the shell is also the direction that the body is coiled. Yes. And in fact, there is a rare condition called hyperstrophy that can happen when the chirality of the shell doesn't match the chirality of the body.
Whoa.
I don't have any more information about that. I don't know what happens to those snails. It sounds bad.
Yeah, that sounds uncomfortable.
Just gonna leave you with that.
It's like putting your left shoe on your right foot and your right shoe on your left. Like,
yeah, just for your whole life.
But your entire body. If you could put your entire body in the wrong-sided suit, that's bizarre. Wow.
And then, of course, speaking of the diversity of snail shells, there are many snails that do not have a shell. These are commonly called slugs. There is no difference between a slug and a snail. This is one of those like frogs and toads kind of situation. A slug is just a word for a gastropod that has no shell. Some slugs have a shell, but it's internal and reduced. So it's still in there. It's kind of like squid, where there is still some remnant of that shell, but it's not like functionally on the outside anymore. Slugs are also not a single group of gastropods. Shell loss has happened over and over again. There are land slugs. There are lots of sea slugs. Among land snails, there are at least 2 different subgroups that are all slugs. Where it's just a whole family of slugs. All the species in them are slugs. In some of these species, there is a shell in the larvae, and then it's lost when they become an adult. So some of them are baby snails that grow into adult slugs. And, as is usually the case, this is not a dichotomy. There is basically every stage in between exists among modern snails. There is actually the term semi-slugs
Yep,
is
yep.
used for snails with a small shell. It looks like a slug that is wearing the shell of a small snail.
Yeah, it's like when an adult wears a kid's backpack. It's
Yes.
just
Some semi-slugs can partially retract into the shell. Some, the shell is covered by the mantle, so you can't actually see the shell itself on the outside. All different. There are some sea slugs that look like what you just described, like an adult wearing a kid's backpack, where this is just a sea slug with a little coiled shell on its back.
Yeah. Yep. And you immediately have the thought of what good is it doing you? And
Yeah.
it's still just there.
There are thousands of species of shellless or reduced shelled gastropods. And jumping off of what you just said, does raise the question of what this means for the snail in question. On the one hand, losing the shell makes them much more maneuverable. Slugs, if you've ever watched a slug, slugs can kind of get wherever they want.
Yeah.
They're very wormy, they're very compressible. They love to hang out underneath bark or underneath rocks. They can squeeze into places that snails with their shells can't access, which means that they can get access to resources, to moisture, and they can avoid predators by going to places that other animals can't get to.
I think you also just answered the question of why I have a soft spot for snails. I think they're very cute and neat. And I have the opposite of that for slugs. They oog me out a little bit.
I think that's a pretty common perspective. Snails are cute and slugs are gross.
And I definitely, one of the biggest reasons for it is I can pick a snail up and not accidentally squish it or have it ooze out of my fingertips the way a slug, you can't pick a slug up well.
Yes.
There's no way to handle a slug that's good. A snail, you can
because without the shell, there's nothing to distract from the fact that this is just a living pile of snot.
Yeah, you're just sentient slime, and and I don't want to shake your hand. I'm sorry.
No. Slugs also are commonly found in places that benefit them. So, for example, slugs often are found in very moist environments because without the shell, right, they don't have a shell to retain moisture. If you live in a moist environment, you don't need that shell. I've also seen it mentioned that slugs might be more common. I don't know if this is like a thing that is observed or if it's just a concept that being a slug might also be helpful in areas with less calcium availability.
Right, yeah.
Where there's just not a lot of shell minerals. So you give up the shell. Slugs, now, of course, the big downside is that you don't have a shell. You don't have defense. Right? That's the big function of the shell. In exchange for that, a lot of slugs have chemical defenses. A lot of slugs are toxic. They're poisonous. A lot of them are camouflaged or mimic other animals. So they have a different approach to defending themselves in a lot of cases.
Yeah, like a bunch of them produce crazy amounts of mucus and just are nasty.
They're just gross. I'm so sorry, slugs. You're gross. Snails are gross too, but they do a good job of hiding it.
Well, yeah, they put on a nice veneer.
Right.
With
they're
the
respectful
shell.
To the rest of us. They mask when they go out.
They're wearing a hat, and it's very professional
wearing
of them.
An egger suit.
If you want a great example of how versatile slugs can be with like their mucus and their defenses, look up banana slugs and like them bungee cording off of tree branches with just mucus.
Yeah, it's so impressive, and I don't want to be anywhere near it. Most slugs, interestingly enough, do have at least some internal remnant of their shell. Which often is a calcium storage organ.
Oh, that makes sense.
Similar to our bones.
Yeah.
It's useful as a little calcium store.
That's cool.
Before we move into the distant past, a little overview of the living species diversity. of slugs and snails. There are so many of them, but they fall into a handful of recognizable groups. Most living species are within two major groups, the cenogastropods and the heterobranchs. Cenogastropods are, I think they're like 60% of living species. They are mostly marine, mostly shelled, not a lot of slugs. They have a single gill. This is something that distinguishes them from most others that have two gills for breathing under the water. Most of these cenogastropods are algae eaters, but they also include a group called neogastropods, which have a whole variety of predatory snails.
Yes.
How they are predatory varies quite a bit. There are moon snails, for example, which use their radula to drill holes in their prey. We've talked about this. You can find fossils, and we've worked with some fossil material where you pick up little fossil clamshells, and they have these perfectly round holes in them from these drilling snails that bore in there and then slurp up the juices.
It looks like someone like drilled a hole to make it into a bead. Yes. But this was done au natural by a snail.
Back in our original Spotlight series, we were joined in one episode by Ranjiv Appa, whose research was on identifying predatory snails by the drill holes that they left behind, which is very, very cool. There are some species of whelks that will stick the edge of their shell, like the opening of the shell, between the shells of bivalves and pry them open to get at the bivalve inside, which is wild.
It's very here's Johnny, like just
yes. And apparently there's been research on fossils identifying damage to the aperture of the shell that reflects this lifestyle.
Yeah.
That this is a snail whose shell edge looks like it was used to pry open clamshells. There are also murex snails, which I think are also drillers, but they've also been known to use the spines on their shell to pry barnacles apart.
Oh, cool.
And of course, also within this group of the neogastropods are cone snails. Cone snails are they've got to be the most famous predatory snails. These are an extremely diverse, I think they're a family with only a handful of genera, but hundreds of species. They're extremely diverse, and they are extremely venomous.
Oh, yeah.
This is the famous, I think there's at least one species or one place where they're called cigarette snails. And the reason is because if you get stung by one, you've got enough time to smoke a cigarette before your life is over.
You're dead before you feel the of the dart.
That I remember, I think it might have been on Most Extreme, which we like to reference a lot. That may be where I heard, because a lot of they're neurotoxic, so they're like have like a paralytic toxin. And I remember hearing somewhere that there's some species that will sting you and you're dead before you hit the ground.
Yeah.
I don't know if that's true. I don't know how much of an exaggeration that is. I'm sure if you're like a child or an immunocompromised person, that might do it.
Or if you're stung in the wrong place.
Yes, absolutely. Like stung in the neck or something.
Mm-hmm.
Cone snails are so cool. Will, would you like to talk about cone snails?
Happily! This is one of my favorites. Cone snails have adapted the structures of other snails into prey capture mechanisms. So the radula that other snails have, which is more like a sandpaper tongue for scraping food, they have adapted the radula down to a harpoon. They've taken this hard structure and gotten rid of all the rasping, and it's now just a hypodermic harpoon. And they have their mouth is on this long proboscis, so they can stretch the mouth out like over the length of the body and the shell away from them. So just this long tube tentacle, and they go after fish mainly. And when they find a unawares fish, they sneak toward it. And once they get close, they harpoon it with the radula and inject the venom. And their venom is so powerful because they need to kill that fish instantly so it doesn't wrestle with them because they are not super powerful.
Yes. Yeah, the venom that is deadly to a human, like within hours, will
Yep.
kill a full-grown human. To a tiny fish that's game over. That's just the end of that fish pretty much instantly.
When you watch videos, the fish gets like 2 shakes and then
Yep.
it stops moving, or at least mostly moving. And then the snail's mouth opens like an umbrella to engulf the fish whole. Like,
Yeah.
you'd think that a snail, now they're gonna sit there and on the body. Nope, all one gulp. So the attack happens faster than we can, see. It's this really fast
Mhm.
dart. The fish jerks a couple of times, goes still, and before it stops moving, usually the mouth is already opening and pulling it in. So within like 15 seconds, the fish can sometimes be out of view inside the mouth of the snail.
Yep. Yeah, these are an unusual group of snails. They're not alone, but in that they ingest their prey. They
Yeah.
just fully swallow whole other animals. Listeners, if you've not seen what we're talking about, look up cone snails on YouTube. There are videos out there. They're so cool. They're
They're
such
very
cool
awesome.
animals.
Another, before we move on from predatory snails, another one of my favorite examples is, I don't remember which conch it is, but conch are just big spiral shelled snails. They often have this long kind of like tube like spike coming off the front of it where they're smelling tentacles and stuff, and they use that to track down prey. And some of them will use that to pin prey to the sand and
Whoa.
allow them to get up on it.
Terrifying. Well,
Yep.
it's so interesting because the thing we haven't really made mention of yet in this discussion is the other famous thing about snails, which is that they are extraordinarily slow.
Yes.
This, now again, there are lots of marine swimming snails, but even still, this is a pile of goo with a shell on it. They're not very fast moving animals. They tend to take life at a very slow pace. So predatory snails you can be super slow and eat plants because plants don't go anywhere. But
Yes.
a predatory snail, they've had to come up with all of these different strategies. How do you get enough food when you have to eat another animal but you move at the pace of a snail? Well, either you break into the home where the other animal is hiding, you pin it down with your shell, or you spearfish.
Yep.
It's really fascinating, all of these different strategies of carnivory in a group of animals that by all accounts shouldn't be able to pull this off.
Yeah. Well, and a lot of them hunt things that are as slow as they are. So you
Yes.
get lots of ones that hunt other snails, ones that hunt worms. There's a great video of a snail eating a worm and just hooking it with the radula, and then the worm is gone.
Yep.
It's like literally within a blink of the eye, it is inside the snail. And I think the best way, if you're like still struggling with the idea of predatory slow animals, snails are a lot like turtles in a lot of ways. And turtles are actually quite good at being predatory. There's a lot of predatory
Yeah.
turtles. They aren't chasing down their prey. They're hunting in ambush ways and things like that.
Or like sea turtles, which are just hunting animals that don't run away, right? You're eating
Exactly.
jellyfish, you're eating stuff like
Yes.
that.
So they are very turtle-ish in how they survive and how they have become so successful, which makes them very cool.
So most all of that diversity that we were just talking about generally is in the gastropods. The other major living group are the heterobranchs, which include a lot of famous marine species. For example, nudibranchs.
Yeah.
Nudibranch, they are not the only sea slugs. There's like sea slug is a thing that has evolved many times, but if you're imagining a sea slug, you're probably thinking of a nudibranch. Nudibranchs are shellless as adults. They're often they've sometimes they've got these wing-like shapes coming off of the body. They're often very brightly colored. They're also, many of them are known to do clever things like stealing the stingers from jellyfish.
Yeah.
They're so cool.
They're just they're like the birds of paradise of the mollusks.
Yes.
Just ornate and bright, and they've got frills and fringes and these like dancing waving structures on their back, and it's just they are so fascinating to look at. And like often when you see a nudibranch, you know you're looking at a nudibranch because they look like a nudibranch because of all these features, but no
Yes.
two nudibranchs look alike. They all look so unique.
Yeah. A lot of them, sometimes they look like fish. Like
Yeah.
I've seen images and videos of nudibranchs where my first thought was I was looking at a reef fish
Mm-hmm.
swimming in the water, and then I get a closer look and I'm like, oh no, that's a snail. That's a snail that's just being beautiful.
Yeah, they're great.
They're like the opposite end of what we were talking about slugs
Yeah. Yep.
before. These are like the answer to that. The what slugs can be beautiful. This is the, and these are also a lot of the ones that are very dangerous.
Mm-hmm.
Right?
Mm-hmm.
They can be poisonous. They can have those stinging cells.
That's often why they're so brightly colored, is to
Yes.
say, don't bite me, it'll be your mistake.
Nudibranchs also often are gill-less. They have no
Right.
gills and are breathing through the skin. They're just absorbing oxygen from the water.
And that's part of the reason they have such like crazy structures, is it increases that surface area and gives them the ability to breathe.
Also within this heterobranch group are a lot of other shelled marine snail species, which have fun names like sea hares, bubble snails, sea butterflies, which I
Yeah.
think are pteropods, which have little flat, like Dumbo ears that they
Yes.
like
Yep.
fly around in the water with.
They flattened their foot out sideways to make these two
Yeah.
wings, and it's adorable. And they've got this little round shell, this little like spherical looking shell.
Yeah, they look like just a little guy.
Yeah, they look like actually they're probably the closest visually to what we had to Navi from Legend of Zelda, just this little
Yes.
orb with wings.
Oh, you're right. All right, we'll keep that in mind for Spooky someday. We'll come back to Nintendo.
Nintendo Part 2.
Also in this heterobranch group are most land species.
Oh, okay.
Land snails, most modern land snails are one group. There's lots of
Mhm.
different groups of them, but most of them are this one major group that includes garden snail. These basically all the snails that you've encountered. So garden snails, banana slugs, which Will mentioned before, are also within this group. These land species, the snails, the ones who are still shelled, in many of them, the mantle cavity has become this highly vascularized structure that functions in oxygen exchange with the air, that functions as a lung.
Yeah.
We talked about this in episode 218 about lungs, that there are land snails that have their own version of a lung in their mantle.
Which is, I remember when I learned that for that episode, I just always kind of assumed that they were doing the like mud skipper thing where you just have gills that you
Mm-hmm.
keep wet and you're breathing through your skin and you're small, so you don't doesn't. No, they made a lung.
Yep, they made their own little shell lung.
Awesome.
Outside of these two major groups, there are plenty of other types of snails. For example, the true limpets are in their own group. Like I said, limpets have evolved many times, but the true limpet, like the limpets, are little clamshell looking snails that are mostly found in rocky intertidal areas. These are considered these days to be the outgroup of gastropods. So they're sister group to all other gastropods, but likely evolved from coil-shelled ancestors.
Huh.
So the limpet shape may not actually be the ancestral condition. It may be that limpets have repeatedly evolved away from that coiled shape.
Crazy.
There are tons of other limpets. There's keyhole limpets and slit limpets in different groups that have evolved multiple times. Also outside those groups are abalones, which are these very famous, large, flat shells that have this glistening interior, that mother of pearl appearance on the inside. There are deep sea snails that have been found, living snails have been found as deep as 10 kilometers. Like, I can't remember if it was in the Marianas Trench or if it was just close to the Marianas Trench, but about as deep as you can get.
Yep.
Snails are found. They also are found on mountains. So snails just run. In fact, and I didn't look this up, they might be the only group of animals, or at least one of the only groups, that they might have the most vertical range of living animal groups.
Yeah, no. Like,
Oof.
minus some, like, isolated ponds that have been populated by fish, by birds or something.
Sure.
But, like, regularly? Yeah, probably.
Because, again, even insects don't get deep into the ocean.
Nope. You also find them on hydrothermal vents, and
Yeah,
you get
you
like
do.
the iron scaled snails and stuff.
That's the last example that I have listed
Oh,
here,
yeah,
which
cool.
are the scaly foot snails,
Yeah.
which is a group. They were actually discovered pretty recently. I was reading a web page that was going over like snail diversity, and it was like, and then there's these these scaly foot snails, and it linked to a SciShow video, and I was like, oh, cool. Did I write that video? And I did, back in like 2019 or something. These are snails that have been found living around hydrothermal vents under the Indian Ocean, and their foot is covered in scales. And the scales and the shell are both coated in a layer of iron sulfide.
Yeah.
Which is so cool. Just chainmail snails.
Yeah, my scales are armor.
My scales are shields.
It's just awesome.
While we're talking about the distinctive features of snails, there is one more thing that I want to mention because it's also going to come up later in the episode. A thing that I skipped over in discussing the anatomy, but now that we have a general sense of the diversity of snails, one of the defining features of snail anatomy is a phenomenon called torsion. Are you familiar with torsion?
Oh, yeah.
Early in development of an individual snail, the mantle cavity, that little fold in the cavity that has the gills and the butt in it, are on the opposite side of the head, right?
Yeah.
Head on one side, butt on the other side, like a normal animal.
As evolution intended.
As they develop, the body shape rotates, which makes the guts form a U shape and places the mantle cavity above the head.
Yeah.
Why they do this is not clear. They all do it.
Yeah.
All gastropods do that. This is a defining feature of gastropods, is this torsion where the body kind of bends over itself during development.
One of the best ways I've ever seen it described was in the True Facts About Snails, where they said it's like if you took your right hand and grabbed your left foot, and your left hand and grabbed your right foot, and pulled real hard until your backside bent over you and flipped over. Because it doesn't just bend, it also twists.
Yep.
Which is like, not only is this a bizarre thing to do, but the fact that they start out, like if they developed with the anus and the mouth on one side, that would be strange. But okay, it slowly shifted. No, you develop like a typical bilateral animal with a front and back end, and then you decided you wanted them both to be the front.
Yeah. So they just have a butt above their head.
Yep.
Now, there are species that aren't torted, but they achieve this by undergoing detorsion.
Yeah, they undo it.
It undoes. So they start out, quote, normal, then they become twisted. Then, as they continue developing, it twists back. Which is this is up there with the recurrent laryngeal nerve, where it's just that classic case of evolution doesn't know what it's doing. Stuff's just happening, and you end up with these extraordinarily inefficient and confusing systems. Yeah, apparently a lot of slugs do this, where they become torted and then they become detorted.
I love it, and it's so uncomfortable to think about.
This is always the case with episodes like this, especially when we're talking about animals that I'm not terribly familiar with, because
Mhm.
I'm not super familiar with slugs and snails. I don't know a whole lot. This episode has been so far, it's been a lot of fun to turn the mic over to Will from time to time and be like, talk about this weird thing. I have increased appreciation for the diversity and bizarreness of gastropods.
They are so unsung, but so successful and so cool once you take a closer look.
And if you think that modern snails are a big diverse deal, wait till we get to the fossil record, because these are the gastropods are a huge deal in studies of paleontology. We'll talk about that after this short break. Stay tuned. One aspect of paleontology that we have mentioned before on the podcast, but which really does get kind of overlooked because we spend so much time talking about vertebrate animals, is that so much of our foundational understanding of the history of Earth, especially the last 500 million years, comes from invertebrates.
Mm-hmm.
Like the big five mass extinctions, the shift from Paleozoic faunas to modern faunas, the transitions between time periods, basically the geologic timescale as we know it for the last 500 million years is built on studies of bivalves and cephalopods and brachiopods and gastropods.
Yeah.
These animals are such a big deal for paleontology, partly because they've been around for basically that whole time, so we can really track them over time, and also because they have shells. And shells
Yep.
are just so nice for paleontology. This is especially handy because without the shell, gastropods are piles of snot, as we have discussed, and that is basically invisible to the fossil record. Gastropods with hard shells have an excellent marine fossil record. And that actually is another important point to add on to the thing I was just saying. Marine fossils. The geologic
Yes.
timescale is based mostly on marine shelled invertebrate fossils.
Yep. We understand the history of our planet through our ocean.
Yes, through seashells.
Yep.
Seashells is how we understand what happens on Earth. Gastropods have been fundamental for research into mass extinctions, major transitional periods, ancient food webs, predator prey relationships. One paper that I read that was talking about this pointed out that the theory of punctuated equilibrium was based originally in large part on looking at snails over
Huh.
time and how they change and how they develop. There are some like 10,000 or something described fossil species of snails. I don't remember. I didn't write the number down, but it's many thousands of species of ancient snails. Most of that is marine. As I mentioned before, freshwater and land snails tend to have much thinner shells.
Mm-hmm. Mm-hmm.
And that means that they are not nearly as common in the fossil record. To give you an idea of the kind of thing we're talking about, marine snails very common, freshwater fossil snails not as common, land snails are the least common in the fossil record. There are only about 2,000 species described of fossil land snails.
It's like they're not even trying.
It's like they're not even there at all. Because once again, we're talking invertebrates now, and shelly invertebrates leave a heck of a fossil record. Yeah, I think it was like it's like 2,000 fossil land snail species, 5,000 freshwater, and then a whole bunch of marine species. There are some exceptions to the shells. There are a handful of cases of soft bodied fossil preserved among snails. There are some in sediment. We'll talk about one example here in just a little bit. There are also snails in amber.
Oh.
There are a variety of cases of Cretaceous amber with snails preserved inside. which is another one of those things that makes total sense
Yeah.
because snails love to hang out around trees.
It also, though, very much brings to there's a post I found of people trying to preserve pumpkins in acrylic to see if they completely encase a pumpkin in acrylic, will it preserve? And the answer was no, because bacteria is already on it. So it's just
Sure.
very slowly rotting and building up gases that are slowly cracking the acrylic open. When you preserve an ant in amber, it's like, yeah, no, that makes sense. This little hard robot body encased preserves perfectly. Preserving a snail feels like that's gonna same sort of like you're just gonna have this cavity of goo.
It doesn't seem like these tend to preserve the body very well.
Yeah.
So you get the shell and you can get some soft tissues. There's at least one example of a amber snail that had at least one tentacle and eye preserved.
Cool.
But the impression I get is that it still isn't actually preserving the body very well.
Yeah.
And as we've, things still decompose in amber.
Yes.
Amber protects against some things from the outside world, like water,
Mm-hmm.
maybe, so, or temperature. Like it's a buffer to some things. But one of the reasons why DNA does not survive very well in amber is because there's still all sorts of exchange happening through the amber.
It is actually quite permeable.
Yes. As far as I can tell, I did some looking, I read some papers. As far as what I've read has told me, there are no fossil slugs.
Yeah. Yeah.
I did not find a single example of one, and I found multiple papers that say there are no fossil slugs. There are no
Wow.
fossil nudibranchs. I don't know. And maybe I missed one. Listeners, if you know about a fossil slug that I missed, reach out and let me know. There are slug-like things, like those weird, like Ediacaran Cambrian things that are sometimes called ancient slug, but like an
Mm-hmm.
actual shellless gastropod, I don't think we have any fossils of those.
Like, it's not surprising that they don't fossilize well because they got rid of the good bit. They got rid of the
Mm-hmm.
shell that would fossilize well. And then they are about as soft bodied as you can get before you become a jelly creature in the
Yes.
sea. But I did have that thought early on when we were starting this of like, we're going to get the fossil, we're going to get to talk about all the fossils. Wait a minute, only part of them. And I
Yeah.
was wondering if this would be the case for some of the groups. Not terribly shocking, but yeah, that's intense because there's a
Yep.
lot of slugs.
It does mean that some lucky person out there is going to get to be the first person to discover a fossil nudibranch.
Yep.
Like someday someone's going to find that one site that has sea slug fossils.
Man, how weird is the preservation going to be at that site to do that?
I don't even know what you would need.
No, if we haven't found one yet, I do not. We might not have come across that kind of fossil site yet.
Gastropods, you will be unsurprised to hear, go back to the Cambrian period. There is some suspicion that mollusks might have originated earlier than that by the Ediacaran, but for sure, mollusks show up by the Cambrian in the famous Cambrian explosion, episode 9, where most of our big modern groups of animals originate. In the early part of the Cambrian, there are a whole lot of mollusk fossils, many of which are single shelled mollusks that have been proposed to maybe be early gastropods or relatives of the first gastropods. There are lots that have been identified as gastropods, but then later it was re-identified. So there's been a lot of sort of back and forth on trying to find what is the first record of gastropods. As of now, there is a promising candidate. There is a group of ancient mollusks called pelagielids, which are tiny, about a couple millimeters long, itty itty bitty. They have a single shell. They are known all over the world. Early and Middle Cambrian, globally distributed. For a long time, their identity has been debated. They have these little spirally shells. They look like you could look at it and say, yeah, that looks like a snail shell. A 2020 study described some specimens. I think these were from Indiana or Illinois, somewhere here in the US. I didn't write it down. So sorry to the pelagielids. A 2020 study described specimens of pelagielids with preserved soft tissues,
Ooh.
including these bristles sticking out near the opening of the shell. These like chitin bristles. This is the structure we do not see in any living gastropods, or indeed, I think, any mollusks. This is a very
Yeah.
unusual structure. The shell, it has these coiled shells, and in some of these, they're pressed into the sand with these bristles preserved alongside them. Because they preserve some of the soft tissue and details of the anatomy, the researchers were able to look at the mantle cavity and respiratory structures, and they noted that the anatomy of these soft tissues that they can see suggests that pelagielids were torted. They seem to exhibit torsion.
Oh, cool.
And if that's correct, then that makes them the best candidates we have for the oldest known gastropods. These go back to the early Cambrian. So these are, 520, 530 million years old.
That's so cool.
It's awesome. Which is another one of those things that if you had asked me and said, could we tell if a snail was all twisted up from the fossils? I was like, I have no idea. I
Yep.
don't know how you would even get a snail.
Yeah, exactly.
And yet the Cambrian. It's just so good for this.
That's awesome. It's also just so satisfying. Like when we talked about when you find out that dinosaurs also encountered ants and dragonfly, like these familiar things to us. There's something very pleasing on basically the entire animal record on Earth. There have been snails.
Yep, there's just always been snails.
And they were here before us. They'll be here long after. This is the planet of snails.
Snail diversity picks up pretty quick after the Cambrian. By the Ordovician, we're already seeing a diversity of shell shapes. I'm not going to go into a whole lot of detail because there's just so much of it. You can look up galleries online of just fossil gastropods. There's tons. Throughout the early Paleozoic, we start to see, long pointy forms of the shells. We start to see different larval types. So today there are larvae that are just plankton that just float around. There are also some that eat plankton, and they tend to have different shell structures. And so we start to see that differentiation in the early parts of the Paleozoic. During this time, most of these ancient snails are interpreted as herbivorous or suspension feeding, although there have been some that have been suggested as maybe early predatory species of snails. We don't have slugs, but genetic studies have suggested that the first shellless gastropods probably evolved early in the Paleozoic. So by the Ordovician, Silurian, Devonian, right, by 400 million years ago or so, we had not modern groups of snails, but all the things that snails do broadly. A lot of that diversity was represented back then. There were also some ancient groups doing things that they don't do today.
Ooh.
One famous example that I think are Ordovician are the giant Maclaratoidea. These are gastropods that preserve large flat shells that look kind of like an oyster. There's just these big flat shells. They can be almost a foot wide. They're big. They are giant gastropods based on the shell structure. So again, in certain cases, you can get that little larval shell on the tip. And so you can trace the development of the shell and how it changed over the life of the animal. The larval structure of the shell is similar to modern algae eaters.
Yeah, okay.
Little grazers. The adult structure seems to suggest that they took on the position of a stationary suspension feeder.
I was wondering.
So they, kind of like what we were talking about with the bivalve snails, these appear to have transitioned from snails to oysters.
Yeah. That's I as soon as you said there are ones doing things they don't do today, that was the first thought I had is this a sessile snail adhered to something snail?
And
That's
it's interesting
awesome.
because in the Paleozoic, bivalves were also around. There were tons. In fact, bivalves were more abundant than gastropods were back then. As we get later in the Paleozoic, in the Carboniferous, so around 300 million years ago, there are reports of what might be the earliest known fossils of freshwater and terrestrial snails. The Carboniferous is kind of the most fitting time for the. If you had asked me when this had happened, the Carboniferous would have been a great guess, because that's when you get forests. It's when plants take over. It's when you get land ecosystems. It might have been the first time that snails could survive in terrestrial ecosystems. We don't know a ton about land snail diversity over the history of snail evolution, because like I said, there's only 2,000 of them. We have they barely exist at all. But there has been a lot of phylogenetic study, a lot of genetic studies and comparing evolutionary families to try to figure out the history of snails leaving the ocean. Genetic evidence combined with fossil evidence suggests that the transition from marine to freshwater has happened more than 30 times throughout the history of gastropods.
Wow.
The transition to land has also happened many times. Like I mentioned before, most modern land snails are one group, but there are also a lot of smaller radiations. Traditionally, a lot of older papers will say that the transition to land happened several times, 10 times, a dozen times. But a study in 2022 combined, again, fossil and modern evidence to suggest that land snails might have originated around 30 times. And according to their data, about half of those originated from freshwater habitats, and the other half came from oceans.
Whoa.
Now, that will make some more sense when I say this next thing. About half of those total transitions were little, like, island populations.
Yes. That's exactly what I was picturing.
These were like, and they mentioned in the paper, they said that a lot of these are like a couple of species.
Yeah.
They moved onto an island, diversified into like 3 or 4 species, and then that was it. But it is a distinct origination of terrestriality in snails.
Ooh, I was expecting double digits for these two things. 30's a lot for both of those.
I think the freshwater transition, if I remember right, the paper said like estimated between 32 and 37.
Yeah. Oh, it's it's like, and this isn't actually how the math works out, but if 30 times snails moved from ocean to freshwater, and then half of those lineages made land snails.
Yes. And half of those went to space.
Yeah, right? Like, we're just leading to the snail that hunts down immortals, and crazy.
Now, I'm going to do an alley. Would you like to guess how many times secondarily aquatic gastropods have evolved? So, land gastropods returning to aquatic habitats.
Oh, no.
We just did an episode 231 about secondarily aquatic tetrapods, right? Vertebrates returning to the water.
The numbers for them have been so ridiculous. I'm scared, and I'm like,
I'm going to give you a hint.
I'm panicking and want to be like 100.
Whatever number you're thinking, lower.
Yep. Okay. Like 10?
According to what I read, 0.
Whoa!
There are apparently no known examples of secondarily aquatic gastropods. Now,
weird.
There's lots of freshwater ones.
Yes.
So there are some that kind of go in and out, but it seems that there are not, at least according to this paper, not any known examples of fully land species becoming fully aquatic again.
I wonder if that's if you run into the issue of, because there's already snails there. Like,
yeah. Or is it that you just got so good at the land that you can't go back?
Yeah. Is it kind of a reverse? Because we've talked about that with secondarily aquatic groups. Mm-hmm. This has been found time and time again with studies that it seems for us vertebrates, for us bony animals, when you return to the water, you hit a point of no return where once you are adapted well enough to be in the water,
Once you're a dolphin,
yeah, you can't evolve back into being that. We do not have any examples of fully aquatic groups returning and making less aquatic descendants. I wonder if snails, they have the opposite situation for terrestriality, that it's a terrestrial ratchet that as they evolve for land,
yeah.
they can't evolve back to the water. Weird. That's the first thing for this episode that's made me uncomfortable. I don't like that.
Yep. Now, it's possible that that paper was missing something, and I don't
Yep.
know. So, listeners, if there's a listener who knows of a secondarily aquatic lineage, they're already furiously typing.
That's great. Well, and even if we find out that there's just one, that's still weird because
Oh, yeah. The fact that a bunch of people who wrote a paper about snail evolution didn't know
Yeah.
of any examples means that there's not enough.
Yeah, because like we once again, at least being when it comes to being semi-aquatic, of like partially returning, that is super common. And there are dozens of examples among vertebrates, and there's tons of examples among insects. It's weird, like even if we find out that there is one lineage, that is unreasonably low.
Yeah. It's odd to find a thing that it seems gastropods can't do.
Yeah.
That this is their
Huh.
limit. Now, listen, the ultimate gastropod is on land.
Yeah.
It's just
Yep.
the trajectory is ever farther out of the water.
Yeah. Jeez. That's crazy.
Throughout the Paleozoic era, we have all of this diversity of gastropods, but gastropods overall are not particularly abundant.
Mhm.
These are oceans that are full of bivalves and trilobites and brachiopods. There's lots of these other groups of invertebrates. Gastropods, there are a lot of, like I said, there are a lot of forms that are similar to modern groups, but these are ancient lineages that were relatively low in abundance. In the Mesozoic era, snails become much more common and much more diverse. This is where we really start to get the familiar diversity of snails. Most modern major groups show up either in the Mesozoic or very shortly after it. Snails are a big deal in the Mesozoic because they were major participants in the Mesozoic marine revolution.
Yeah.
We did a whole episode about that, episode 174. Go listen to that for more details. But the overview is that the Mesozoic marine revolution was characterized in part by an increase in shell-crushing predators. This was a major influence on the structure of aquatic ecosystems. Gastropods are an interesting part of this equation because they were on both sides of this change.
Yep.
So in the Mesozoic, we start to see shell structures in gastropods that are indicative of more mobility, more active lifestyles of snails. We see a lot more thick and spiny shells. In the Paleozoic, most gastropod shells are like smooth.
Mhm.
There's not a whole lot of ornamentation on the shells. In the Mesozoic, we start getting knobs and spines and ridges to protect them from rays and crustaceans and all these things that are out there now crushing hard-shelled prey. You also see a rise in predatory snails. We see abundant sites with drill holes in the shells of other gastropods or other mollusks. These are, I believe they're not super abundant, especially in the early Mesozoic, but where you find them, they tend to be pretty common.
Yeah. It's great to think that what snails really needed was an arms race to get going. That they're war profiteers. They do
Well, they were
best during
like-
conflict.
When we were all being barnacles and clams, it was fine, but what we were really born to be is tanks.
Yes, yep, exactly. It was built for war.
True limpets are known as far back as the Triassic period. And then we start to see more things like moon snails and murex snails in especially the later half of the Mesozoic, associated with drill holes and damage to other shells. So snails were a really big part of this transition, both as predators and prey. So a ton of research into the Mesozoic marine revolution is snails.
Yeah, just so cool.
And then I have comparatively little to say about the Cenozoic, because by the time we get to the Cenozoic era, we have mostly our familiar groups of snails. One major time period of note is the Paleogene. Shortly after the end of the Cretaceous is when we find the oldest examples of sea butterflies, the pteropods, the little flappy guys we were talking about, and cone snails.
Ooh, yay.
Cone snails have been around for some 60 million years or so, according to the fossil record. They're really a Cenozoic feature, which is interesting.
It's they noticed that someone was like, man, after the dinosaurs went, it just feels like things are less scary. And they're like, all right, we can take care of that.
There was a group of snails that looked at all of the We'll show you a marine revolution. They were like drilling into shells. We'll do one better. And then apparently the Neogene, so this is 5 to 30 million years ago, exhibits the all-time highest gastropod diversity.
Really?
Like, we are recently gastropod. They've just been getting better. Gastropods have just been on this upward trend until very recently. As the Quaternary sets in, like the Ice Age sets in, we do start to see a drop in diversity. The cooler climates have been less beneficial for gastropods. They are obviously still a big deal, but the Ice Age wasn't the best for them, and humans have been really bad for gastropods.
Yep.
If you look up gastropod research outside of paleontology, you are mostly seeing conservation, because snails are often really important indicator species, so they can help reflect the health of an ecosystem. They're also, just so many of them are threatened. Yes. I think there are dozens that have gone extinct in the last century or so. They're really, for as diverse and successful as they are, individual gastropods are not very hardy organisms.
Well, they've got a bunch of things going against them. They're sensitive to the environment. They've got this permeable, moist skin like frogs do. They can't migrate very well. So, like, if we start ruining a pond, that entire population of snails might be in jeopardy, because it's not easy for them to relocate to another place because they're slow and small. And then they are really vulnerable to ocean acidification because they're needing to make shells. So they're suffering just like coral is, as we are messing up the carbon cycle in the ocean.
Yep. So they are, again, they're still almost insect level diverse in the modern world. On the whole, they're doing pretty well. But yeah, they're having a harder time these days. I am very hopeful for them that their trajectory over the last 500 million years will just continue into the future, and eventually this will be a snail world.
Yes. Yep.
One other fun thing that I found while we're talking about the recent thing that I found mentioned while I was looking these up, snail shells are also a huge important part of human history.
Oh, that makes sense. Yeah.
And obviously they've been used for like jewelry and things like that. But cowrie shells or cowrie shells were currency for thousands of years. It's like one of the oldest and most common forms of money are cowrie shells, little snail shells. Apparently, in some places, according to what I read, there were still some places that used them as currency as recently as the mid 1900s.
Wow.
Which is so cool.
That's very cool. Yeah, like it makes sense because they're beautiful little objects, so it makes sense that we're enamored by them. And very cool that they've become useful. It also makes sense that we did something with the shells, because we've also been eating snails for a very long time. So like they've been a part of our diet. So it makes sense that we're like, you know what, we got all these leftover shells after eating them. Let's do something with them.
Well, and a thing that I saw noted multiple times when I was reading about this is that they are extremely difficult to counterfeit.
Oh, yeah.
So if you're handed, especially, you know, for most of the last several thousand years, if someone hands you a cowrie shell, you know it's real.
Yeah.
Because how could you make a fake one?
That's a really good point.
Yeah. Gastropods, very cool. This has been, as often is the case, a real bird's eye view, a real breeze by of the diversity of this group. There are so many cool, fascinating species. This is one of those groups that not only do I suspect a lot of our listeners have favorites, but I suspect a lot of our listeners have personal stories of
Yeah.
of favorite or memorable interactions with gastropods.
Mm-hmm. Yeah. I think one of my earliest is after a rain, a whole bunch of them came out to either take advantage of or get away from the oversaturation. And so the sidewalks were just covered in snails moving around. And you don't usually see hordes of snails. And it was very, very neat.
Listeners, please get in the comments or join our Discord and share your snail and slug stories. We'd be happy to hear them. Before we end the episode, there is one last thing to do, and that is our patron question. One of the benefits that our patrons can receive in exchange for their wonderful support of us on Patreon is the ability to submit questions for us to answer here at the end of the episodes. Will, what shall we answer today?
Our question is from Georgia. I recently re-listened to an episode in which the patron question asked whether sidewinder snakes had a preferred side, and David expressed surprise at being able to find an answer.
I did.
Could you walk us through how you would conduct a search for a question like this? How would your search strategy differ if it's a subject you're not as familiar with?
That is an excellent question. Yeah, somebody submitted a patron question that asked, did sidewinder snakes have a preferred way, to move left or right? And I did express in the episode that I was shocked to have found the answer to that question. My expectation was to do a little bit of searching and then give up.
Yep.
The way that I searched for that, and the way that I often will do it, is I'll go to like Google Scholar and search, in that case, probably sidewinder locomotion, sidewinder snake locomotion, something like that. And then once I've seen what kind of results come up for that, looking to see if there are keywords mentioned in those paper titles that I forgot to mention. So sometimes they'll be like kinematics, and I'm go, oh, okay, cool. That apparently is a word that is related to this subject that I can search for. In that case, if you search up sidewinder locomotion, you get a lot of papers about robots. And so I got a lot of papers about robots, and there was one, and really it was just I picked a couple, and one of them was creating snaky robots and discussing, and they were studying sidewinder snakes and then building robots modeled off of those snakes. And there happened to be a line in the paper that said they didn't seem to have a preferred direction. So I got lucky enough to find a paper that was in detail describing the locomotion of these snakes, which is what I was hoping to find, and I didn't expect to find that. That's usually how I go about a search like that, is I'll search for some keywords. If nothing is coming up on Google Scholar, there are other places that you can search. Right? There are science databases like Web of Science and stuff. Sometimes I'll put it into just regular Google, and sometimes I'll specifically put it into Google News to see if there was some sort of popular article written about it at some point. So with an unusual search like that, my strategy is really just search for what I know will get me close. See if I pick up on any keywords or a particular author who might be common in that area that I can then search for more specifically, and then hope.
Yeah.
That was also for a patron question. So my plan really was I'm going to look at like a couple of papers. If I can't find an answer, the answer will just be no, and then we'll move on. If I needed to find the answer to something like that, then what I would probably end up doing next is email somebody
Yeah.
and reach out, right? Find somebody who works on sidewinder snakes and just be like, hey, you've done research on sidewinders for 30 years. Do you know the answer to this question? Because if it hasn't been written about in an actual piece of scientific literature, someone may have noticed it and not written it down somewhere.
Yes, exactly. Like there's a bunch of that knowledge that is known but not documented because it's not critical to studies being done.
Yes. Well, I'm also kind of not surprised that I found the answer in a paper that wasn't really about snakes,
Yep.
because that seems like the kind of answer that maybe snake scientists wouldn't ever think to put in a paper,
Yes.
but
Yep.
that someone outside of it was like when you talk to kids and kids are like, what about the this? And you're like, I've never thought about that because I have solidified my perspective enough as an adult or as an expert that I never thought to think about that question. But that a bunch of roboticists came in and they were like, hey, this influences how we're going to build our robots.
Yep.
Do
Yep.
snakes move like this?
Yeah. No, it was like most of the times nowadays when I learn something new about crocodilians, it's from like watching clips from people who work with crocodilians, not papers, because the papers aren't usually mentioning the fact that tail wagging, like swinging the tail back and forth, is a form of display in some crocodilians. We don't fully know what it's for every time, but it is a behavior that I'd never heard of.
As far as the last part of the question, how would my search strategy differ if it's a subject I'm not as familiar with? Snakes is easy because I can throw out a bunch of keywords about snakes and biomechanics and such. If I were asked to look for, like, I don't know, medical information or, astrobiology stuff, that is going to get into an area where my initial search is going to struggle.
Mm-hmm.
So what I might have to do is first look at like a Wikipedia article or some popular news articles and find some keywords. Like,
Yes.
what are the words that people do use in reference to this? Or even easier than that, I ask somebody. I would reach out to somebody and I would ask. I've been actually on both sides of that. I forget what it was, but not too long ago, some friend of mine reached out and was like, hey, I'm looking for this information. Do you know how to look for that? And I was like, yeah, here's a couple of keywords that will be under that you might not be familiar with because you're not familiar with this field. I have also, sometimes I'll get a question. And well, I think I mentioned, speaking of kids' questions, I think I mentioned this recently, that I was asked if T-Rex could bite its own tail like a dog. And I did a little bit of literature search, but mostly just for like, how do we study flexibility in ancient, in dinosaur tails? The first thing I did was I went online and I reached out to a couple of friends of mine who are tyrannosaur experts. And I was like, hey, I have no I have no way to know how to find the answer to this question. I doubt it's in any literature. You're a top expert in this particular group of animals. You tell me what you think. And that is going to be the answer to the question. Well, it's like if people ask plant questions. I'm not going to look for literature on a plant question. I'm going to ask Allie, and Allie's going to tell me the answer.
Yeah. Well, and if you don't have anyone immediate to contact, or you're not feeling brave enough or up to sending an email, a tool that I often use is either on the wiki to start off, or when I find a paper that looks promising, is Control F, Control Find, and then start typing in what you're looking for so that you don't have to read the whole thing. And you might see that, they don't, like, I want to know about the teeth of this animal. Here's a good article. Teeth. That didn't come up at all. They don't mention the teeth here. Moving on.
Yes. I did that with at least one or two of my references here. I think it was when I was looking for examples of fossil slugs. And I would find a paper that was like a review of fossil gastropods, and I would Control F slug or nudibranch. It's like, all right, these are not mentioned in this paper at all. That seems like a pretty good answer.
Yep. So yeah, it's there's, for some subjects and some questions, it's just going to be a long search, but there are definitely ways to speed it up.
Yes.
And hopefully you get lucky.
And if you are a fan of our podcast, one of the convenient answers is if you go to our Discord is filled with scientists and science nerds.
Yep.
There's so much there. It's truly incredible the amount of knowledge in our Discord community.
It's really cool.
It's so cool. People are in there having conversations about stuff that I've never heard of. It's awesome.
Yep.
Go check it. People are also sharing memes and stuff, so don't be intimidated. Sometimes it gets very sciencey, but also a lot of the time it's just like pictures of pets. So check it out if you are so inclined. Thank you, Georgia, for that question. Thank you to all of our patrons for their incredible support. Thank you to everybody for listening, for requesting, for supporting the podcast, for participating in the Discord and such. An extra special thanks to our top tier patrons, Sarah May, Danielle Loves Bugs, and Jeff Ellington. We appreciate you oh so much every episode. Listeners, be sure to check out the blog post that will be up on our website after this episode goes up. There's a bunch of cool pictures of snails being adorable. There's some pictures of slugs, but they're like adorable pictures of slugs. So check it. It's not like the last episode when I was trying to find good pictures for flies. And I was actively trying to be like, all right, let's find like nice pictures of flies because I don't want to gross anybody out, and flies are gross. It's easy to find cute pictures of slugs. Slugs are way cuter in a picture.
Oh yes,
than they are in person.
When you zoom in, they've just got this little face and this little just puckered mouth, and it's very silly looking.
This is the first episode of 2026, which means by the time you're hearing this, you can, if you haven't already, go listen to the end of the year Q&A for 2025. And we will soon be having an anniversary celebration for the 9-year anniversary of the podcast. We'll be doing a live stream for everybody to join. We'll make some announcements. We're going to have a great old time. And we have some special projects coming up pretty soon. Poke E is going to be releasing in February. And then there's maybe some other special projects that by the time this releases, we might be ready to talk about. But as of this recording, we're not. So I'm not even going to mention them. We release episodes every fortnight. Next episode is Allie is going to be joining us to talk about plants. And then shortly after that, we've got a Darwin Day episode to do. So there's a whole bunch of fun stuff coming up, even in just the main episodes of the podcast.
So many friends have been coming to visit us on the podcast.
So many friends. Listeners, thank you so much. This has been great. Something about snails.
Once again, just all of you hold in your mind how horrifying torsion is.
They're all torted. And torted is not a thing that I made up. Yeah, so this is the thing. If you listen to me talk a lot, I do like to do that. I like to make up words because it's funny.
You like to verb a word.
Absolutely. I love to verb a word. Detorted is a word that I saw written in a paper. I'm not on board with that. I don't like it.
I was not consulted. I do not approve.
Detorted sounds like what it is.
Yeah.
I don't want to think all that much about what it is because it seems terrible. It's like that guy in Iron Man 2 on the screen. Yeah. That guy got torted.
Gastropodic torsion.
All right. Well, stay tort, listeners, or untorted. Don't get torted out there.
Get tort this weekend.
Don't get tort this weekend. Don't do it unless you're a snail.
Tort responsibly.
All right. Well, that's a great outro. Bye.
Bye.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.